So here we have a video on linear differential equations, specifically those with exact equations. And as I've said, it's just like spotting an old friend in a crowd. And that old friend to us is our good old friend, the product rule. If we look at what we've got written out here, we can see that we have a linear, on the left hand side, a linear differential equation, i.e. I've got dy by dx and just the function y. Let's work from the right hand side. If I were to differentiate this function using the product rule, I know that what I would do would be to differentiate f of x and leave y. I would then add the function f of x times by the derivative of y. Now, if I derive y with respect to x, I do that implicitly to get dy by dx. And that's exactly what we have on the right hand, on the left hand side over here, f of x times dy by dx and f prime of x times y. The trick is to be able to see that the function in front of dy by dx can be derived to give the function in front of y, and that's what we're going to look for every time. So here's our first example. We know it's a linear differential equation because I've got dy by dx and y. I look in front of dy by dx and I think, if I differentiate this function, does it give me the function in front of y? The differential of x is obviously 1, so clearly this does. So I can rewrite the left hand side of this as the derivative of x times y. If I derive x, I get 1 times y. If I derive y and leave x, I end up with x times dy by dx. So this is equal to sine of x. Now, if I integrate both sides with respect to x, okay, if I integrate this derivative, I end up with x times y, and if I integrate sine of x, I end up with minus cosine of x. Now, it's important at this point that we remember we're integrating, so I must include my constant of integration. Second example. Maybe you'd like to pause this video and have a go. So I can see that again I've got a linear differential equation, dy by dx followed by y, and I can see that the function in front of the dy by dx is x to the power of 5. If I differentiate that, I end up with 5x to the power of 4. So I know that the left hand side can be expressed as dy by dx, d by dx, sorry, of x to the power of 5 times by y, which must be equal to 2x. Then, integrating both sides, I end up with x to the power of 5y is equal to x squared, and again, mustn't forget that constant of integration. Here's example number 3. Again, you might like to pause the video at this point and have a go yourself. I can see that I've got a linear differential equation, dy by dx, and y. If I differentiate the function in front of dy by dx, I get minus sine of x. Hurrah! Meaning that my left hand side can be expressed as d by dx of cosine of x times by y, which is equal to sec squared of x. Now, integrating both sides with respect to x, I end up with cosine of x times y is equal to sec squared. Can be tricky to integrate unless you can remember that obviously sec squared integrates to Mr. tan. Don't forget that constant of integration plus c. Now I'm going to choose to just rewrite my left hand side as y times cosine of x, and the reason for that is because I don't want there to be any confusion with me multiplying x by y and then finding cosine or what have you. So I like to keep my functions nice and separate. And that's it. Example number 4. Maybe you would like to pause and have a go, or maybe you'd just like to watch me do it again. Again, if I look, I've got a linear differential equation, And I can see that if I differentiate 1 over x, I do end up with 1 over x squared. Minus 1 over x squared. Very important. Minus 1 over x squared. So we can express the left-hand side as d by dx of 1 over x times by y, which is equal to e to the power of x. Again, integrate both sides with respect to x, and I end up with y over x is equal to the integral of e to the x is e to the x. Don't forget that constant of integration. Again, we can choose to rewrite this, if we would like, as y is equal to x e to the x plus c lots of x. And here is a nice general form for our solution. Example number 5. Again, you may like to pause the video and have a go. If not, here comes the solution. dy by dx and y. So I've got a linear differential equation. I can see that if I differentiate log of x, I end up with 1 over x. So I know that the left-hand side can be expressed as d by dx of log of x times by y, which is equal to 5. Integrate both sides with respect to x, and I end up with log of x times y equal to 5x plus c. Never forget that plus c. Again, so that there's no confusion about me multiplying x by y and taking logarithms, or taking logarithms and then multiplying by y, I'm going to tidy this up to write it as log of y times log of x, which is equal to 5x plus our constant of integration. So the next video in this series is going to be on integrating factors. Thanks for watching, and don't forget to check out my website.